Hello, so let's go to check chapter 6. Before that, we will finish chapter 5. So let me share my screen with you and let's start. So for chapter 5, what we left is the first one is okay. So computing this descriptive statistics. So this is okay. And so let me change my input method and turn into markdown. And what we are looking at is, okay, so I want to use the old data frame, which is frame. So what we want is, okay, let me sum it together. So what do we have? What we have is each column sum up, right? Sum up number. And then what we are looking at is, so you can use access columns or access one sum across the columns instead, which is access is equal to 1. Okay, so this is how we add these columns together. So, and the next part is mean. And so NA values are excluded unless the entire slice is NA. This can be disabled with the skip NA option. For example, we have df dot. Okay, let me change some of the value in this data frame into NA. Then what we can external headphones. Okay, that's correct. So let's change it. Frame dot iLook np dot nan. Okay. So right now we change a value in frame into an an, right? And what I want is mean. So is this correct? I want to use access equals to columns and skip an A is equal to false. Okay. And here access is equal to columns. See, so you want to skip an A or not, then you will have a different result. And options for reduction methods, we also have level, which is reduce groups by level if the access is like multi-index. So some methods like IDX minimum, IDX minimum, in the index maximum return indirect statistics that like the index value where the minimum or maximum values are attained. So for example, okay, frame dot idx max. This is so for BDE, B the biggest is Utah. For D the biggest is Ohio. And for E the biggest thing should be Texas. Yeah, so, okay. Yeah, because we changed the frame. So we is to, for the first one is Utah. And frame, index minimum. So this is a way to find out the biggest or smallest value for each index, actually. And then the next thing is COMSUM. So frame dot COMSUM cumulative sum up. So what do we do? So it's accumulations. I'm not sure what it add. So let's see. Okay. Okay. So we use for each column, you can see the second one is equal to the first one plus the second original one. And then what we will look at is, okay, I want to look at a reduction or accumulation. I want to know this graph. So it producing multiple summary statistics in one shot. Okay, I need some pencil. Yeah. Where is my pencil box? Okay, it is here. Let's continue. So, describe. Okay, I always use describe, which to show the summary statistics. And there are also a lot of descriptive and summary statistics like count, describe, minimum, maximum, sum, mean, median, probability, product, value, standard deviation, skew, and curve, and some cumulative product of values. The next part we will look at is correlation and covariance. So some summary statistics like correlation and covariance are computed from pairs of arguments. So, okay, there are a lot of, so we will look at several frame, data frames, but I still want to use what we have, frame. So we use frame. Let's check the okay, so we have, okay, I will not use the older one, and I think this data reader is interesting, so I will use it. Count install pandas dot and then data reader. Okay, we could not find it, so how about pip install pandas data reader, and then we will import pandas dot data reader dot data as app, and then all data is equal to taker colon web dot get data dot yahoo taker, and then for taker in, this is how we actually to find out those stocks. IBM, FT, GOOG. Okay, so let's see what's in all data. Not that much. Right. So the next step we will do is to create what we will do is to create data frame based on price is equal to pd.data frame and so taker data. Okay, and then ADG close. ADG close. For taker and comma data in or data dot atoms. So this is what we have for price. It's in there, okay. Date and the name of the column is the name of the company, and this is stock adjust closed price. And the next thing we want to get in is volume. VLUME, volume, taker data. Okay, volume, right? So we have volume, we have price. We have volume, we have price. And the next step we want to do is that, okay, we can get the percentage change in price. Price dot BCT change. Okay. And the correlation method of series computes the correlation of the overlapping non-NA aligned by index values into series. So how to do it? First, returns is equal to this one. And then we have returns, which Microsoft and dot CORR return. Okay, be the, so we want to check if the returns of Microsoft has some like negative or positive correlation with IBM stock price change. So yeah, the correlation is negative, but is positive, but not very high. And let's check the covariance CLV. Okay. So since MS Microsoft is a valid Python attribute, we can also select these columns using more concise syntax. For example, Yeah, we don't need to use this bracket. We just use this one, and then we can easy to catch this columns. So that's what we do. And so we can also use correlation and covariance to show a covariance matrix or correlation matrix. For example, returns dot CORR, and this is what we have. And we can also do covariance. Okay. The next step is use the correlation weight method. We can compute pairwise correlations between a data frame's columns or rows with another series or data frame passing a series returns a series with the correlation value computed for each column. So for example, returns dot COR weight and returns dot IBM. The next thing is passing a data frame computes the correlations of matching column names. So here we compute correlations of percent change with volume. So we have the same thing, but we will compute with volume data frame, VOLUME. So with the volume, the price actually has all negative correlations, right? And if we pass with access, then things will change. Only check day by day, row by row instead. Then the next step is to find out unique values, value counts, and membership. So how can we do that is, okay, we want, remember we have frame, right? So, or we have some like series. Okay, so I have this series 3, series 2. Okay, series. So for series, I just want a unique value. Okay, data frame object. How about 1? So we only have this unique value here, right? So this gives me an array of unique values in a series. So first I need to get a series, and also like series dot value counts. Okay, we only have geek and geek. There are 2 geek, right? And the next part is, okay, for value counts, we can add a lot of interesting things in value counts. For example, the series is sorted by value in descending order as a convenience, but we can also sort it from the largest one to the smallest one. The next thing is in performs a vectorized set membership check and can be useful in filtering a data set down to a subset of values in a series or column in a data frame. So for example, what we can do is we have we have a series is S and PD dot series, and then what we will have is B, C. So this is the series, and we do value count. And what I want is sort equals to force. And is in is also very interesting. For example, a mask is equal to s dot is in or s dot index dot is in. And then we will put as mask. Okay, it seems like the result is not correct. So how about s dot index mask? Okay, it's still not correct. So what's in object? What's in Okay, let's see what's in S. So we have A and we don't have D. So it will only show us A. It will not show us anything other than D and A because we don't have D in this series. So it will only show us the A. And related to is in is the index get indexer method gives us an index array from an array of possibly non-distinct values into another array of distinct values. So how to understand this is that, okay, we have still we have S, then we have another series which is okay, which is U PD dot series A B. So PD series. Okay, sorry. Parenthesis first, and so we have U, and then we want to PD dot index unique values. No, U dot get indexer dot s. So let's see, get indexer. In S, the indexer is like this, and in U, the indexer is these two. So it gives us an index array from an array of possibly non-distinct values into another array of distinct values. Actually, I'd kind of like to show us precision. So yeah, I actually need to know more about this part. Another last thing is we want to look at is that we want to compute a histogram on multiple related columns in a data frame. If we want to do that, we will pass in pandas value counts to this data frame's apply function gives. So for example, so we have returns. We have returns here and apply parentheses pd dot value counts, and then view and a. Here, the row labels in the result are the distinct values occurring in all of the columns. The values are the respective counts of these values in each column. So it's a very good way to help you to actually draw the histogram, which I have never seen it before, and I think it's very funny and interesting to use this, and it's very useful. So let's go to chapter 6, which is data loading, storage, and file formats. So I will start to look at chapter 6. Let's start on chapter 6. So chapter 6, the first one is reading and writing data, which is easy because we will use we will read CSV and a lot of other things every day, right? Read CSV, read JSON, and like read Excel, and so. But I think there are lots of parameters that I have never used before, so I will check that part. And also we will reading text files in pieces, writing data to text format, and working with the delimited formats. And we will look at JSON and XML, HTML. And we also will look at the binary data formats using HDF5 format, reading Microsoft. Okay, and interacting with the databases. So this part is not that hard, and I think I need to find their original, because before that I have checked a lot of, I have input a lot of the code by myself. But right now we have some like CSV we need to read in. So I will go to the GitHub and to read these, read in this CSV. I will download that CSV, download all that data set it asked, the book asked. So let's go to that GitHub, which is, okay, Python for data analysis, GitHub. So this is Jupyter Notebook, and we are looking at chapter 6 right now. Okay, and so first is examples. Okay, so it's here, which is nice, and let me download all of them and start to use this big folder to do it, because I don't think that, because if I cannot read in all of them, then I cannot do anything with this. So I really think that for chapter 6, I can just use 30 minutes to finish. So let me end this part here, because, okay, actually, let me talk about later about this part. So on desktop, we are checking this one, and we are in chapter 6. And yeah, let's start for a while and then I will end this video so we can check left of chapter 6 in next video. So we read in the exercise 1 CSV, and there are some parameters here, like in read data, read data in the function. So for example, indexing. So with indexing, we can treat one or more columns as return data frame and whether to get column names from the file. And we can type inference and data conversion. We can do date time parsing. We can iterating. We can do some unclean data issues. So the first thing is that we start with a small CSV text file like this, and we have column name, we have the contents, and the next thing we will look at is, okay, so it's comma delimitated. We can use read CSV to read it. So right now, it is a data frame, it is a tabular data frame, right? And a file will not always have a header row. So consider this row, consider this this file. We don't have a header. So what should we do is that actually we can allow pandas to assign default column names, right, which is 0, 1, 2, 3, but that's not the one that we want to use. And what we can do else is to add the column names that we want. So right now it looks better. And suppose we want the message column to be index of the return data frame. So we can set the index here, which is, so names is equal to names. And at the same time, we set the index column to the new column name. So it's like this. And then the next part is, so in the event that we want to form a hierarchical or multi-index from multi-values, we can pass in a list of column numbers or names. So this is what we read in, and we want to index. So what should we do is index column. There are two of columns here. And the next thing we can look at is, so a table may not have a fixed delimiter, using white space or other patterns to separate fields. So for example, our data frame is like this. See, there are lots of like white space. So what we can do is we still use read CSV file, and we can use some regular expression to eliminate these spaces, right? And let's check the next data frame. So which is like this. I think we need to skip some rows like this one and this two, right? So we can skip rows and get what we want. Okay, for the last part we are looking at is, okay, we have some NA here. So when we see some NAs, what should we do? So pandas use a set of common occurrence simultaneous. So missing data is usually either not presented or marked some centennial value. So what is centennial value is NA and null. So you can see here is the result, which is NA. And the NA values can take either list or set of strings to consider missing values. So we can change the missing values to null. And different NA centennials can be specific for each column in a dict. So for examples, okay, for message, for the message column, we want to change full and NA, and in something we want to change to NA. So this part is very rare for me because we can read something, we can exchange actually NA value to something, to some, or it can say that we can assign which one of the value to change to NA when we read the data in. So there are also lots of function arguments for read CSV, so we can check it later. And the next part I want to look at is reading text files in PCs. So when processing very large files or figure out the right set of arguments to correctly process a large file, we may only want to read in a small piece of the file or enter it through smaller chunks for the file. So this part is very important because right now I'm looking at how to help the students to read in large amounts of file. So first we can we make the pandas display settings more compact. And then there are 10,000 rows, right? And what we will do is we only read a small number of rows. This one, we only read 5 of them in. And at the same time, what we can do is specify our chunk size as a number of rows. So chunker, and so when we have chunker, what can we do? So the text file reader object returned by read_csv allows you to iterate over the parts of the file according to the chunk size. For example, we can iterate over this CSV exercise 6, aggregating the value counts in the key column. And the text parser also equipped with a getChunk method that enables you to read pieces of an arbitrary size. So yeah, that's all for this part. I think it's pretty long, so we can finish chapter 6 in next video. So thank you for watching.